So, welcome back, everyone. This is another project, a SQL project to be precise. This is just one of my SQL projects. So, I just now I cleaned this data. I cleaned this table, which is called transaction, in one of my video called data cleaning with SQL 2. So I cleaned this table. So I will not be going through the process of importing the CSV file and then doing some cleaning and just basically importing the CSV file. I will not be doing it in this video. You can go back to the previous video and watch how I was able to import the file, the CSV file into my database table, and how I was able to clean it up. Because when I imported them, it was not this way. It was a little bit different. So I was able to clean it up after importation. So this time around, we'll be talking about SQL queries. Now we'll be running some SQL queries. I think it's just 15 SQL queries. That's what we'll be running today. Now, most of my nowadays I just do SQL project. The reason I'm doing more SQL projects is so that I can get used to SQL. Like I always say, I said it earlier that I didn't start earlier with SQL. And that is very important for any data analyst. You have to start with SQL before any other language, even before Python, sometimes before Excel. I think so. Not everybody, Excel is not that important for me, because I think with the aid of SQL and Python, you can be able to do what Excel cannot do. So I will just get started instead of taking your time. Now this is where we'll be doing our SQL query. Now I normally use the PG2. The Cycle PG2, sorry, the Python library for communicating with SQL, PostgreSQL. So you could also use the pgadmin, but I love using the Cycle PG2. Using the pgadmin is not fun for me, using Cycle PG2 to communicate with the database and do some data, either data cleaning, or you just want to get some information from your database. Now, there's a fun part about this pgadmin. You can also download, after you can also save your file. And you can also plot it, but I don't think the graph visualizer is more efficient like likes of Tableau and Microsoft PowerPoint. Sorry, Microsoft Power BI. So let's just start with our query. Normally I import my library. Then after that, I give it the necessary parameters, which is the username, the password, and the name of my database. Now, the name of my database, I normally say name. This is the name of my database. This is my databases. This is one of it, learning, and also this is another one, Postgres. I think this is the default database. So when I say the name of my database, this is what I'm referring to, learning. So, okay, this is the database name, user, and password. So let me run that. Then I should create a connection and a cursor, very important. Now, the first query, this is the first query. It was asking what is the total number of distinct customers in the database. Now, first of all, count the what? Use the count function, which is an aggregation function. We now use a distinct. Now, distinct selects non-duplicates. What I mean non-duplicate is, what distinct means is that assuming there are many duplicates in a particular table or in a particular row, it selects one of it instead of taking all the duplicates. It's only the distinct part of it, which is just a single value of that. So you now use the customer ID. Now, when you're using count, you could use customer ID. You could use any column you want to use, because all columns have the same rows. So at the end of the day, even though you use asterisk, it doesn't really, But we'll also use customer ID in case we're just finding for a distinct customer. You can also use customer name, anyone that suits you. It's just a little bit the same. So let's run that. Then we'll execute. After executing, then we check the results. Now it's just 50,000, which is just the row of our database. So meaning that all customers, meaning that they are not, there's no situation where they were two the same customer which patronized this. Sorry, it means that there was no situation where we have a customer doing a transaction twice. Now, if you watch over here, is 10 out of 10. Okay, let me remove this limit to show you how many we are having here. It's 50,000. So you see, what it means is that this 50,000 means that all customers are unique to each other, which means that we don't have a particular customer that made a transaction twice. So it makes sense. Like it makes a lot of sense. So the next query is what is the total number of distinct customers in the database? Okay, sorry, I made a mistake over there. That's not the second query. The second query is to find the average. Is to find the average. Okay. Is to find the average. Sorry, it's to find the average of average total amount. Sorry, average transaction amount for each category. Now, I normally sometimes when I just see each, my mind goes to group by, because you are trying to select a particular stuff based on a group of another column. What I mean is that we are trying to group the categories based on what is. So we are going to group the transaction amount based on what's the category. That's to say each based on each category. I will say the first category, category 1, you list out the transaction amount, category 2, you understand, something like that. So that's why we use the group by, and grouping by what category, obviously. We want to find the average of the transaction amount. So run that and get this. So for the travel, this is the average, electronics and others market. So yeah, so I should identify the top 5. Okay, it's correct over here. So it's identify the top 5 customers with the highest total transaction amount. The top 5 customers with the highest total transaction amount. Now, first of all, get the customer ID, its name. Then we'll now check the sum. Remember, we're talking about total. Whenever you see total, remember, we're talking about sum or addition. Or yeah, things sum of the total amount. Total what amount? This is total amount, sum of it. Sorry, sum of the transaction amount as total amount, which is what we have here. From what our transaction table. Yeah, so you should group by the customer ID and the what customer name. Then order by what in descending, order by transaction, total transaction amount in descending order. Why we did this is to for us to get the top 5. Remember, when we are using the top 5, it means that the one at the top is the highest. So that's why we order it by in descending order. So make sure that the highest transaction amount or the highest total transaction amount should be at the top. They will not limit it to 5 since we are dealing with what the top 5. These are our results over here. So Elizabeth, Lutz, these are ID, then these are transaction amount, total transaction amount. Then this is for this person too, and others too. Okay, so let's go to the 4th query, which is calculate. I want to make sure they are okay, correct. So she calculate the total transaction amount for each month. Also group by, because whenever I see each, your mind should go towards group by. Now this is not a rule, but I'm just trying to show you how I quickly identify which type of query I use when I see a particular question. Now remember, I said you should find the total transaction amount for each month. Now our table is actually in years. If you watch year, month, and day, year, month, and day. So we will have to extract the month. That will use the extract function to get the month from the transaction date. You see it as month. Now we now get the total. Of course, we don't get the transaction amount. Again, the total transaction amount as total transaction amount from our transaction table. We now group by this, which is the extraction here, because that's what we'll be grouping by each month, and the order by what the month. Now let's run that. We'll be using more of these extracts in other examples. Just don't worry, I will explain it more in details. Okay, yeah. So we should determine the average age of male and female customers separately. I'm trying to get the average age of male and female customers separately. Now we have to select the gender first of all, because that has to do with the male and the female. They will now have to extract again the age. Sorry, what am I even saying? We don't have to, sorry, not the age. How we're able to get the age is that now we are on 2024, which is, I don't know, you may not see my cursor. It was down here, my time section there. You have this 1st February 2024. So what this does is that it extracts the year from this current year or day or let me just use year since we are dealing with year, from this current year, which is 2024, and it extracts the year of the person's birth date. Now this is the birth date. Okay, you see here 1949, 1999, 2003, and all that. So it extracts that. It first of all extracts the year for this year we are in. They extract the birth date of the person, and it gives an alias of average age. It's then now grouped by what? The gender. Let's run that. Okay, that was good. So this is the average age of male and female. Now the next is to find the customer who made the largest single transaction. We'll first of all get the customer name. Now we'll not use the max. The max is used to get the highest value between a group of what values. Like that's the max. Then the lowest is the mean or minimum. Is the maximum or minimum. That is just an aggregation function. I think so, yeah. Then transaction amount as the largest transaction from the transaction. Then she group by the transaction, then the customer name, since we are dealing with an aggregation function. Then we should order by the largest transaction, which is this one, in descending order, and we should limit it to 1 since we are getting the largest, not larger, or not the large transaction amount. We're not trying to get large transaction amount from different customers. We're trying to get the largest, which is the, let me just say, the highest or biggest, or at the top. That's why I limit it to 1, something like that. Okay, run that. I was what? Elizabeth Lutz. She made a lot of transactions though. Okay. Okay, the next one is to identify the customer who has made transaction in all available categories. Now we have to select the customer ID, the customer name from all transactions. Now we have to now these are where statements. So I have to now give a condition. Now for the customer ID in, we should now give a subquery. Now this is a subquery inside this query. So what is the subquery doing is selecting the customer ID from transaction. There is now grouping by the customer ID. Is not setting a condition. Whenever you are dealing with group by, I want to have a condition. You cannot use where, you have to use having. So having that the count for the distinct category, which is the count for distinct category. Now, previously I've talked about categories, like the distinct ones. I think that was at the top. Okay, wait. Distinct categories. Okay, that is not, okay, I'm so sorry, that is not, I was looking for, I thought it was something else. Okay, yeah, we'll now have to get the distinct categories, like the travel, electronics, and all the distinct, we should get the count of them, and make sure if it equals to the count. Okay, over here, okay, we're also selecting, okay, let me explain this before this. We are selecting the count of the distinct categories from our table to make sure if it's equals to the count of the category. Again, now the reason for this is you have to identify a customer who has made transaction in all available categories. We're trying to make sure that this place now is equals to this. Obviously we have okay, I will run that to see. Obviously we have an empty string because there was no customers who made transaction in all available categories. Okay, let me run that to show you what I mean. We had an empty string here because there was no customer who have made transaction in all available categories. The reason is this. Remember when we were checking the customer, that is the first part when I told you about. Let me show you what I mean. Okay, the first part when I'm talking about get to distinct customers, each and every customer appeared only once. So for them, it's not possible for them to make transaction more than once. Or more than one time. It's not okay. So that's why we got an empty list here, because there is no way, or in the table it was not recorded that someone made a transaction in all available categories, because we're trying to get the count of the distinct categories from our table and make sure it's equal to the distinct categories. Now the reason for this is this. If we are selecting the count of the distinct category from our transaction table and making sure it's equals to the count of the category, you understand? Of course, they will not be equal. Remember, if it's equal, we could have a value, but they're not actually equal. So that is what just happened over here. Okay, let me run along. Okay, yeah, over here I'm saying calculate the total transaction amount for each merchant. Now merchant was this merchant here, all these ones here. Okay, so we now have to, for each merchant, normally we use the group by again, so I don't have to explain this much that way. Let me run that, and this is what we have. Okay, and the next one is to find the month with the highest and lowest transaction amount. First of all, we now have to use a CTE, which is a common table expression. Now I normally use this table. I normally call it a mini table. I normally use, especially in more complex queries. Queries, complex queries are queries like subqueries, CTE, which is the common table expression, Windows function. Yeah, those are complex queries. So now I have to now create. You normally use the width, and I give it a name as. So I give it monthly totals. Then I extract the month from the transaction date as month. Then I get transaction sum of the transaction amount from, and I group by the month, which is this one here. Okay, then I now select everything from this what mini table or CTE, and order the transaction in descending order and limit it to 1. Then I union it again because I combined it with this one again. I selected everything from the monthly totals again and order is by in ascending order. Now remember this, the reason for this, the reason why I use the union or is to combine the result of these two. Now if you use only union, you will get a different result, but union all will combine the result. Or if you use only union, this will only execute, but this will not be executed. So using the union all, you can execute both and you get your results, because we're trying to get the highest and the lowest transaction amount. For find the months. Okay, the months, we're going to get the months with the largest and the lowest transaction amount. That's why I was selecting everything, because everything implies that we're selecting the month and the transaction amount for the what. Now this descending order implies for the highest transaction amount, and the ascending order is for the what lowest. Lowest. So let's run that, and as you see, 7. This is transaction amount, and 10, and this is transaction amount. Now the first one is the highest, and this one is what the lowest. I think so. Yeah. So in month 7, which is September, that's when we have the lowest transaction amount, and in month 10, which is month, not September, month 7 I think is July. Yeah, maybe. But month 10 is October. So having that. So let's run the next one. Say identify customers who made transaction on their birthday. This is really cool. You made a transaction on your birthday. Yeah. Okay, well, after that, the customer ID, the transaction date from what the transaction. So I have to extract the month from their birth date. We have to equate it with the month from their transaction date. Remember, identify customer who made the transaction on their transaction on their birthdays. So their birth date must be equals to the transaction date. And also remember, when you use and, both conditions will be correct. So this one should be correct and this one should be correct for it to execute. Now also extract the day from the birthday, and also the day for the transaction date. Now the month, the year does not matter here. It does not matter, because if someone was like now, okay, someone was given birth in 2001. Let me say September 10, 2001. That is his birth date. Now let me say he made a transaction in September 10, 2024. You see, in this situation now, the person has completed these two conditions, this first one and the second one, which is the person name will be, person ID will be listed, and the transaction date he or she made the transaction. So because we have, okay, let me run that. We also have an empty query because nobody made a transaction on their birthday. So that makes a lot of sense, that the month must be equal to, and also the day must be equal to, but the year will not be equal to, because someone they gave birth to on 2001, September 10, 2001 cannot actually transact something in that same day. Unless if it was done on behalf of the person, something like that. Okay, the next one says calculate the percentage of transaction made by each gender. Now we have to select the gender. They have to now count the customer ID as the transaction count, and then customer ID should also count the customer ID times 100. Now we're trying to get the percentage. When you're dealing with percentages, is either when you're dealing with percentage, you multiply by 100. Remember, when you're dealing with percentage, you multiply by what? 100. Now we have to now select the count from the transaction as the percentage. Then we now have to divide it by the count of the customer ID times what? 100. Now remember, the count of the customer ID is 50,000. So 50,000 times 100 divided by the count of the transaction from what? The transaction. Then group by what? Gender. So let's run that. So this is the percentage for male and female. Remember, we group by what? Gender. This makes sense. Okay, let me explain this again. I think some people may not understand this. Okay, yeah, we're trying to get the count of the customer, which is 50,000. The customer, because we're having 50,000 customers, times 100 divided by what? The same count again, because this also will give us 50,000 again. So it's just like 50,000 times 100 divided by 50,000. That's 50,000 divided by 50,000 to get the what? The percentage. They will now have to group it by the gender. Now we have to do it for the female and also the male. That's why we have to now get the percentage. We have 55% for female and okay, let me say 56% approximately. Then 44% for what? Males. So I think more female made more transactions than males. I think that makes sense. Okay. The next one, we have to find the average transaction amount for each categories in the last quarter. I have to select the category, then the average amount as average transaction amount, sorry, from the transaction. So where now remember I say we should find the average amount for each category in the last quarter. So we have to use the extract again. Okay, sorry, the extract is not needed here. We use date truncate the date. Okay, yeah, we have to forget the transaction date. Make sure it's greater than. Now for quarter is 3 months per year. We're having 4 quarters, which is 4 times 3, which is 12 months. We're having 3 months in each quarter. So we have to get the quarter, the current date, which is January, because I did. Okay, now it's February, sorry, which is February. Then the interval is 3 months, which is because it's a quarter. Remember, it's a quarter for the current date. So we want to make sure that our transaction date is greater than or equals to this, and also make sure our transaction date is less than this. Now, while we are making or explaining the reason for this condition, now we also truncate the date again, the quarter, and what's the current date. Now, what we're doing here is that this is the transaction date. Make sure it's greater than or equals to what? We will not get the current. What we did, we get the current date, which is 1st of February. The day I was doing this, I'm doing this video, which is 1st of February. Then we now minus 3 months out of it, so that we can know when the quarter started. We now remove 3 months out of it. You understand? That's why I say it should be greater than or equals to what? The transaction date. Now the transaction date, no, we didn't minus 3 months because the transaction date is older than the current date. Sorry, we added 3 months to it. And what does it mean is that transaction date, it should be greater than or equals to this, and transaction date also be less than this. What this basically does is that so I'll not be confusing anyone. What this does is that it just, okay, let me say today is February. Remember the transaction date. Let me pick a particular transaction date to make it more easier. Now this is 2023. I think March 30th, 2023. So remember, I find the average transaction for each category in the last quarter. Remember, the last quarter of 2023 is, I think, is October, November, December. We're now in February now. Now, assuming, okay, let me say we want to calculate the quarter from now. Remember, the quarter from now, based on that transaction date, will be sorry, wait, I'm coming. Let me check out something. So the transaction date will be okay. So as I was saying, there was something that was confusing me, so I've fixed that. I was having some okay. Now what this is saying is that the transaction date, which is 2023 30th of this, which is this, is saying that the transaction date should be less than today. Remember, I'm using the current date per quarter, so it should be less than today, which is 2nd February. It should be less than that, and it also be greater than today minus 3 months, because you see the minus here. I said minus before because I was thinking that it was able to you add 3 months, but I didn't remember it was minus. So I have to clarify that first of all, so to avoid confusion. So now, so we have to make sure that the transaction date is greater than or equal to today, which is the current date, minus 3 months. Now, if you minus 3 months from today, we'll be having something like, I think it's January, December, November. I think it will be November. Yeah, I think it's November. So today minus 3 months. So make sure that it is not what greater than. It's not greater than what the transaction date, which is not the transaction date should be greater than it, and also so what the transaction date should also be less than today. So it makes sense that because we are finding the average transaction amount for each category in the last quarter. There's no way we can be including tomorrow. It doesn't make any sense. So we have to make sure that 3 months before today is included, and it should not be greater than the transaction amount, and transaction date should not be the 3 months minus today should not be greater than transaction amount. Transaction date, and 3 months. And the transaction date should not be greater than. Remember, that will use less than. Should not be greater than was today. For us to not get to the last quarter. The transaction amount for each category in the last quarter. And group by category here. So let's run that. So as you can see, in this place, this is the transaction. This is the transaction amount for each category. For each category for the last 3 months. So you know how I will get it. We got our last 3 months. Remember, the transaction date should be greater than what? Today minus what? 3 months. And the transaction date also should also be less than what? Today. So let's get that. Okay. So the next query is you should identify the customer who has not made any transaction in the last 6 months. Now, I think this project is more of dealing with dates and time. And sometimes if you're not even careful with dates and time, you may, if you're not careful with it, you may, run into a lot of mistakes. So when handling anything time series, you should make sure you be careful with it. So now we should identify the customers who have not made any transaction in the last 6 months. Now, first of all, select the distinct customer ID, of course. They are distinct already, even though without this, but I just added that. The customer name from our transaction. Then we should now have what? We should now select the customer ID where. Remember where. Then we'll now give a condition. So you should select the customer ID from our table. Where now this is a sub query. Remember. Where transaction date is greater than or equals to the current date minus 6 months. Remember, the first one was minus 3 months because we were talking about quarter, but this one is minus 6 months. This is it. So today minus 6 months because we are trying to find the customers who has not made any transaction in the last 6 months. So if today is February, then minus 6 months will be January, December, November, October, September. I think September, yeah, it should be September. So I trying to find customers who has not made any transaction since September till now. And also make sure that transaction date is not greater than what today. Make sure it's what is less than below today. Something like that. So once this condition is clear, this where statement will be executed because it's based on the condition that it will be executed, and the query will be executed all along. It will now select those customers that what meet up with the condition over here. So let's run that. Okay, we have some customers that way. Okay, these are them. Okay, so now let's take the second to the last query. Now determine the total, the top 3 merchants with the highest average transaction amount. Now I have to get the merchant name, their transaction amount. From this, they group by that in descending order. I think I've been doing most of this, so it's not that hard to explain. It's not hard to grasp. I've done something like that. So we use group by, order by, limit, and that. So now I have to calculate the last one, which is query 15. We'll have to calculate the month-over-month growth rate in transaction amount. We have to now do it in minute table. We have to select the year because we'll be needing it for transaction date as year. Then also extract the month from transaction date as month. Then the total transaction amount again from our transaction dates. Then we have to group by the year and the month. Remember, sometimes okay, I think that is already okay. Now I have to select the year, month, transaction amount, then lag over. Now what this lag does, remember we're dealing with month over month. I wrote a formula actually on the for you to calculate the growth rate, I have to deal with the current month minus the previous month divided by this is the formula for growth rate divided by what the previous month times 100. This is what we are doing here. Lag the total amount over, then we'll now order by year and month as what previous month. Sorry, this is what we used to get the previous month. This is a Windows function, lag, to get the transaction amount over. You have to order by year and month to get the previous month. Now this lag, which means what transaction amounts that happened before the previous month, that it lags. You know, it's not something lag, it's something that is behind you, or So I'm just trying to use that logic to explain it in more simple terms. Now I have to give a case normally for conditions. So when lag, which is this, over this is null, then you print out null. But if it's not null, you should what? Get the transaction amount minus the lag itself over blah blah blah, which is just the same as this, then divided by the lag total amount. This like this is the formula itself, that growth rate formula. Remember, this is the current month. Wait, let me show you. This is the current month minus the previous month divided by previous month, which is this. This is the current month. Transaction amount of the current month, which is now in the month we are in now. Then this is the transaction amount of the previous month. Remember, that's why I use the word lag. No, months before. We now give it a. Remember, when you use only lag, PostgreSQL may not understand what you are saying. You have to now give it this over, then order by the year and month. You see. So what this is saying in essence is that just get me the month and the year and the month previously before today, which is 2nd of February, which is 2/1/2024, which is 2nd of February 2024. So give me the previous month, year and month of that divided by the same thing again, then times 100. So that is our formula, which is the that is as the growth rate from our monthly list, and we should order by what the year and month. If we run that, these are the transactions that has been done previously before to what today. So this is the end of the word project. Now, okay, I forgot to add something here, which is the connection.close, because it's very, very important for you to close your connection and your cursor when you are done with CyclePG2. Very important for security reasons. So I have to close that to make sure No, hackers doesn't tamper with it. So thank you all for this. This was actually, based on time. Like I said before, when you are dealing with time series, open your eyes. Do not because sometimes it may look confusing. So thank you all and goodbye.